Hello everyone, welcome to this session. So in our previous sessions we have completed two modules. So in this session we are going to start with the new module. This is the second module of your syllabus. The name of the module is Infinite Fourier Transforms. Okay, so let's go with the definition first of all, like how this is represented mathematically. Okay. So here the thing says that let S be a non-zero real parameter. Okay, this S stands for a expression. Okay, then the infinite of a function f of x is denoted by f cap of s or f of the function f of s or f of s. Okay, and it is generally defined by the infinite Fourier transform is generally given as f of s is equal to integral from minus infinity to infinity f of x into e power isx dx. Okay, and here this I stands for an imaginary term. Okay, I stands for an imaginary term, and this is the general form of a infinite Fourier transform to be represented. Okay, this infinite Fourier transform is also known as a complex Fourier transform or simply known as a Fourier transform. Okay, so in this way we are generally representing the infinite Fourier transform. Similarly, we have also, if we have a Fourier transform, we have its inverse Fourier transform. Okay, let's see now what this inverse Fourier transform says. The inverse Fourier transform of f cap of s is denoted by f inverse of f cap of s, and it is defined as f inverse of f cap of x is equal to 1 by 2 pi interval from minus infinity to infinity f cap of s into e power minus isx into ds. See here it is ds, not dx. Okay, and what is this f cap of s? That is equal to f of s. Okay, so in order to determine the inverse Fourier transform, first we need to determine the Fourier transform of the function, that is f of s. This is nothing, this also can be written as f cap of s. It's one and the same. Okay, so in order to determine its inverse Fourier transform, we need to be knowing the f of s value. Whatever we get f of s, right, in the question, first we need to find f of s, and to find the inverse of it, here in place of f cap of s we need to substitute the whatever we got as f of s, then we need to find its inverse. Okay, it is also equal to f of x. Okay, this is also equal to f of x. While solving the problem, instead of writing this f inverse of f cap of s, we can also write it as simply f of x. Okay, so this was all about the basic standard Fourier transform and also its inverse Fourier transform. Okay, so now again I'll just brush it up. This is the general form of a Fourier transform, that is from minus infinity to infinity f of x e power isx dx, where I is the imaginary term. Okay, and in order to find its inverse Fourier transform, first we need to find this f of s so that we can substitute it in the inverse Fourier transform. The inverse Fourier transform is given by f of x is equal to 1 by 2 pi from the integral minus infinity to infinity f of s or f cap of s into e power minus isx dx, where this I is the imaginary term. Okay, now the parameter here is ds. Okay, not dx. We need to be very careful. Here it is ds. Okay, so whenever we substitute the value of x during the Bernoulli's rule and all, we need to substitute the value of s in this function. Okay, not x. Okay, yeah, so this was all about the basics of this chapter. Okay, so now we'll solve a few problems related to the standard Fourier transforms. Okay, we are going to have various problems. Okay. So this is your first question of this module. Okay, so the question says that find the Fourier transform for the function f of x, where the two conditions are given for f of x, that is f of x is 1 if x lies between minus 1 to 1. This corresponds to even mod x. Okay, we can even write it as mod x, or f of x is 0 if x is strictly greater than 1. Hence we need to evaluate from integral 0 to infinity sin x by x dx. Okay, first we need to find the Fourier transform of this function. Then in order to evaluate this, we need to use the inverse Fourier transform. Okay, Okay, so now we'll write the formula for f of s. We know that it is minus infinity to infinity f of x e power isx dx. Okay, so now here we need to split the limits as per the given question. So the limits are from minus infinity to infinity, right? So now how we can split this? In order to split this, we need to split it first from minus infinity to minus 1. Okay, that will be your first integral. Then the next integral is from minus 1 to plus 1. Okay, where the value of x lies. And then we need to the next integral is from 1 to infinity. This completes the whole cycle of minus infinity to infinity. Okay, so now let's I'll write it for you, then you will understand this very clearly. Okay, see, I have written it this way. I have split the limits from minus infinity to infinity in 3 parts. Okay, so now how to solve this? So now here, if you observe this integral carefully from minus infinity to minus 1, there is no f of x value given for this interval, right? So we can neglect this part. We can neglect this part while doing the sum. So now consider these two integrals. Okay, in this, the interval from minus 1 to 1, we have the standard f of x value, that is 1. Okay, and from 1 to infinity, that is the condition is x is greater than 1. Whenever x is strictly greater than 1, that is from interval 1 to infinity, we have the f of x value as 0, right? So we know that if we substitute the f of x value as 0, 0 into anything is 0, and the integral of 0 is 0 only, right? So we can even neglect this term. So only this term is left for us to solve. Okay, so this way we need to solve most of the problems related to this concept. Okay, so now for this, let's substitute the f of x and let's solve. Okay, yeah, so we need to solve now for this. F of s is equal to, from minus 1 to 1, the value of f of x in the given question is 1. Substitute that. So I'll directly write it as e power isx into dx. It is 1, right? So I'll not write that one. Okay, so now we need to integrate this function. Okay, that is, we need to integrate e power isx divided by the coefficient of e power x, right? The coefficient of x here is is, so bring that is down from the interval minus 1 to 1. Okay, so now f of s is equal to, take this 1 by is common outside, into the upper limit and the lower limit, that is e power is into 1, right? The upper limit is 1, so I'll write it e power is minus e power I into s into minus 1, that is equal to, I'll write it 1 here, f of s is equal to 1 by is into e power is minus e power minus is, right? So now if we look at this carefully, we can get an hyperbolic function, right? Not hyperbolic function, but similar to that, we have one formula for this. We know that e power I theta minus e power minus I theta divided by 2i is equal to sine theta, right? We have a general formula for this. Okay, so similar way we need to substitute this as sine s. So for that, the denominator 2i is missing. So in order to place the denominator here, we need to multiply it to the numerator as well. So the further the solving is like this: 1 by is into 2i into e power is minus e power minus is by 2i. Okay, so I have just multiplied the numerator and denominator by 2i. Okay, is equal to 2i by is. We note that this corresponds to sine of s, right? This is the general formula for that. So now cancel this 1i. So the left out terms are f of s is equal to 2 sine s by s. So this is your required Fourier transform. So now from this we need to evaluate the other question, that is from 0 to infinity sin x by x dx. So now we will solve that. So now we need to evaluate the function that is 0 to infinity sin x by x dx. We need to find its value. Okay. So for that we know that by inverse Fourier transform, the value of f of x, which is equal to f inverse of f of s, right, that is equal to minus infinity to infinity 1 by 2 pi into f of s into e power minus isx into ds. Okay, so now we'll solve it. Yeah, so that is f of x is equal to 1 by 2 pi from minus infinity to infinity. The value of f of s which we have got is 2 sin s by s into e power minus isx into ds. Okay. So now we need to in the next step we need to put the value of x is equal to 0 here. Okay. Why? Because we need to eliminate this term, because the question is we need to find the value of integral from 0 to infinity sin x by x dx, right? So we need to, this much we have written it, right? So we need to reduce it to the form which is given in the question, that is we need to reduce it in such a way that we need to substitute some particular values so that we reach the final destination. That is, our goal here is to reach the answer, that is this 0 to infinity sin x by x. We need to reach till there. For that, this term is disturbing us, right? See, here we have sin s by s, 2 sin s by s. This is the easier way. So this term is disturbing us. So in order to make this neglect this term, if we substitute the value of x as 0, we know that e to the power 0 is equal to 1, right? So this gets eliminated. Okay, so similar way we need to solve these type of problems. Okay. So now put the value of x is equal to 0 in this case. Okay. Now x is 0, so f of 0 is equal to 1 by 2 pi integral from minus infinity to infinity 2 sin s by s into 1 into ds. Since e power 0 is 1, right, so I have written it as 1. So now this function we have got it, right, 2 sin s by s. We need to verify it that whether it is an even function. Okay. In these type of problems we need to first verify whatever we have got here, whether it is an even function or not. If it is an even function, we can write the integral, that is from minus infinity to infinity, as 2 times of 0 to infinity. Okay, we can write it like, if this function is an even function, okay, then only we can write it as f it is equal to minus infinity to infinity is equal to 2 times of 0 to infinity, because the question here in the integral they have asked it as from 0 to infinity, right, but the interval here is from minus infinity to infinity. Okay, so now let's put it as f of s is equal to 2 sin s by s, right? Now let's consider f of minus s, that is 2 into sine of minus s divided by minus s. Sine of minus s is equal to minus sine s, right? So it becomes minus 2 sine s by minus s. So with minus minus gets cancelled, it equal to 2 sine s by s, that is nothing than f of s. So we can say that it is an even function, right? Yeah. So here f of minus s is equal to f of s, that is the integral from minus infinity to 0 as well as from 0 to infinity. Here the values of this infinity, this remains the same, so it becomes 0 to infinity twice. That's why we write it as minus infinity to infinity is equal to 2 times of 0 to infinity. Okay, yeah. So now this function becomes as f of 0 is equal to 1 by 2 pi into 2 times of 0 to infinity, since it's an even function, so 2 sine s by s into ds. Okay, So now we need to find the value of f of 0, that is f of x. Here we have the value of f of 0 as 1. Why? Because the interval is from minus 1 to 1, where the value of x lies between minus 1 and 1. So we can write it as f of 0 is equal to 1 in this case. Okay, so let's substitute the value of f of 0 as 1. That is equal to, here we can cancel this 2 from here and from here. So the remaining terms are 2 by pi into integral from 0 to infinity sine s by s into ds. Okay, so bring this 2 by pi to the other side, cross multiply, so this goes up and 2 comes down, is equal to 0 to infinity sine s by s into ds. Okay, so now we have nearly reached the destination, that is we need to find the interval from 0 to infinity sine x by x into dx, right? But in place of x we have here s. So the last step we need to do here is we need to replace the parameter s by x. So in order to get our final answer. Okay, so nothing much to do here, we need to put s is equal to x. So the final answer we get is 0 to infinity, wherever s is there, replace it by x into dx is equal to pi by 2. So that this is all we need to find, right? They have given in the question to evaluate the value of 0 to infinity sin x by x into dx is equal to pi by 2. This is our final answer. Okay, yeah, so we will solve few more problems. So this is the second question of this module, that is we need to find the Fourier transform of the function f of x is equal to e power minus a into mod x, where a is strictly greater than 0, that is the a whatever is there is a positive integer. Okay, so now in order to solve this we need to know what do you mean by mod x. What is the function mod, what does the function mod x say? So by definition of mod x we know that mod x is minus x whenever x lies between minus infinity to 0, that is whenever x is negative, and mod x is a positive x whenever x lies between 0 to infinity, that is whenever x is a positive number, that is from 0 to infinity, the value of mod x here is x, and it is minus x when the x lies between minus infinity to 0. Okay, yeah, so first we need to write this. So now we know that by the definition of Fourier transform we know that f of s is equal to minus infinity to infinity f of x e power isx into dx. So the same thing we need to do here, we need to split the limits, that is from one is from minus infinity to 0 and another is from 0 to infinity. Okay, so in such a way we need to write it. So now f of s is equal to minus infinity to 0 e power minus a, and the function mod x, right? Here in place of mod x we need to replace it by minus x, because from the interval minus infinity to 0 whatever is the mod x is equal to minus x, right? So we need to replace mod x by minus x here. Okay, into e power isx into dx plus from interval 0 to infinity e power minus a into the whenever it is from 0 to infinity the value is positive x. Okay, so replace mod x by positive x into e power isx into dx. So these are the steps, so please observe this carefully. So now what it becomes, from minus infinity to 0 e power minus a into minus x, so minus into minus is plus, so it becomes e power ax into e power isx into dx plus 0 to infinity e power minus ax into e power isx into dx. Okay, so now we need to add the powers, that is since the bases are same, that is e. So now add the powers, that is e power ax plus isx into dx plus from 0 to infinity e power minus ax plus isx into dx. Okay, So in these two we can observe that x is common, right? So take that x outside. So the further the function becomes minus infinity to 0 e into a plus is into x, that is I've taken x outside, dx plus from 0 to infinity e power is minus a into x. See, I've written this is first since it's a positive sum, so I've written is first, after that I've written a, and I've taken x common outside from this two, okay, dx. So now we've done with some of the simplifications. So now we need to write the integrals, that is substitute the integrals. Integral of e power a plus is into x, that is e power a plus is into x divided by the coefficient of x here is a plus is, right? And the limits are from minus infinity to 0 plus e power is minus a into x divided by is minus a, where the limits are from 0 to infinity, okay? So now split the limits, solve for the limits. So now we need to split the limits, that is e power upper limit is 0, right? So x value is 0, so 0 into anything is 0, so this becomes e power 0 divided by a plus is minus, so now the lower limit is minus infinity, right? So minus infinity, so infinity into anything is equal to infinity only, right? So we'll write it as e power infinity divided by a plus is plus, for this we need to write it as e power infinity, so infinity into anything is again infinity divided by is minus a minus 0, right? 0, if x value is 0, 0 into anything is 0, so it becomes e power 0 divided by is minus a. So now we know that e power 0 is equal to 1, right? And anything to the base as to the power 0 is equal to 1, right? So now f of s is equal to 1 divided by a plus is minus, and e power infinity, whenever there is e power infinity, the standard value of e power infinity is equal to 0, okay? You need to remember this, okay? E power infinity or e power minus infinity is equal to 0, okay? So this becomes as 0 divided by a plus is plus e power infinity is again 0 divided by is minus a minus 1 divided by is minus a. So now 0 divided by anything is equal to 0, right? So these two terms gets cancelled. So the remaining terms are 1 divided by a plus is minus 1 divided by is minus a. So now the rest is the simplification part, that is we need to cross multiply and multiply the common denominator, that is is minus a minus of a plus is divided by a plus is into is minus a, okay? So now this is equal to, so now in order to make this denominator of the form a plus b into a minus b, if you look at this denominator carefully, it is of the form of this only, a plus b into a minus b. If we interchange the places of a plus is as is plus a, so then we get it as is plus a into is minus a, that's of the form a plus b into a minus b. That a plus b into a minus b, we know that it is equal to a square minus b square, right? So in same thing I am going to do it here also. So now this becomes is minus a, multiply the minus sign, minus a minus is divided by is plus a into is minus a. So that is equal to, we can cancel is, and the denominator is minus a, that is equal to minus 2a divided by is the whole square minus a square, right? Yeah, so by further simplification we get it as 2a divided by, so multiply this square, so this becomes I square s square, right, minus a square. So now whatever this I or I square, whatever is there, right, that is an imaginary term, that we have a standard value for this term, right, that is, we know that I is equal to square root of 1, right. The imaginary term, we represent it as whenever the square root inside is a negative, that is square root of minus 1. So in order to find the value of I square, we need to, if we take square on both sides, this becomes minus 1 the whole square, that is square root and square get cancelled. The standard value of I square is equal to minus 1, right, minus 1, I square is equal to minus 1. So the same thing I am going to substitute here as well. So this becomes minus 2a divided by minus 1 the s square minus a square, that is equal to minus 2a divided by minus s square minus a square is equal to minus 2a divided by, I will take this minus sign common from this term and I will write it as a square plus s square, and I will cancel this minus term, so that the remaining f of s, finally the answer we get it as 2a divided by a square plus s square. So this is your required answer for this question. Okay, so look at all the steps very carefully. So how we have reached to the final answer? By substituting the values for I and all the things here, limits from 0 to infinity and all. Okay, yeah, so in this session that's all. We have solved 2 important problems. So in the next session we are going to solve few more problems of this concept. Okay, thank you.